Hi, my name is Sydney, and today we are going to talk about the difference between Stack and Heap when it comes to programming. In this video, I will specifically be coding in Java, but remember that Stack and Heap also pertain to other programming languages as well. Before we get into exactly what Stack and Heap is, let's start with a simple example. Let's say we want to print the number 2003. We would start off with declaring and initializing a variable, let's call it birth year, and giving it the value of 2003. Then we would print that variable in a print statement. If we click run, you can see that the number 2003 is printed. Let's try something else now. I'm going to declare an array of type int and hold multiple years in it. If we attempt to do the same thing we did before with printing the variable, we get a different type of output. Printing the array does not print out the specific values we put in it. Instead, we get a bunch of wacky numbers, and I can assure you that it is not an error. Why is that? That's where Stack and Heap come in. When we print something in a print statement, we are printing the value that's in the stack memory. The stack stores the actual value of primitive types. Remember, primitive types include integers, doubles, characters, and Boolean values. When using these types, you know exactly how much computer memory you need to store that value, so that much space is provided on the stack. Keep in mind, each method has its own stack, so if you have an integer and a Boolean in one method, they won't exist on the stack in another method. Here's an example. If I assign a variable of type double with the number 12.5, that variable is stored on the stack. As variables are created or declared, they are added to the bottom of the stack. Unlike primitive types, the stack stores an address, or that wacky mix of numbers, of the memory location for object types. Object types include strings and arrays. So where are the values that the object holds, like the years from our array before? They are stored in the heap. While the stack stores the object's location, heap stores the actual value. So in order to print the values, we need to reference a specific element in the heap. The heap holds more complex information than the stack cannot contain. When accessing the heap, the stack must provide us with the location of the information in order for us to print that. Here's another example. Say I have an array holding objects of type animal. Each object is assigned an address on the stack, which points to a specific location on the heap. Once the computer recognizes this location, it can then print the specific values of the object, for instance, the species and name of the animal. Stack memory lives only within the program itself, so once the code is executed and the program is done running, the information on the stack is replaced. Since the heap contains more complex information, it lives outside of the specific program's memory, so it can be accessed more than once.